something called truffle framework. That's like when you want to work in your own editor, and usually use truffle. It's a Node.js kind of dependency that allows you to write smart contracts and write unit tests for it. So the first thing that you do in Solidity is just define the version using Pragma Solidity. So I'm going to use Pragma Solidity 0421. And the next thing that we want to do is define a contract name. So the contract is basically means like a class. Like if you're a Ruby programmer, you will use a class something and the name of the class. So in Solidity it's called contract. So then let's say we want to define a public variable, unsigned integer, 256 public something. So with this line I declare the state variable inside of this contract, and I made the visibility public. So that means it automatically created a getter function for this variable. So it's the same way as defining like this. If let's say we made it private, and it would return something variable, so we not have a same names. So it's essentially the same thing if when this variable is declared as public. So let's deploy this first contract. It doesn't do anything. It just only has one variable. It does return the variable, and we haven't defined a setter method. And I just want to show you how to deploy it. So in Remix, you can click a create button, and I use the JavaScript VM environment. So environment is something that you specify which network you want to talk to at this particular moment. So there are quite a few networks. So if you can install the MetaMask extension, which is like a Chrome extension, which is your Ethereum wallet. And in MetaMask, you can select which network you want to talk to. So there is like a public mainnet Ethereum, which is a main network where the real Ether is transferring. And there are some test networks like Robson, Kovan, Ringby, and we also have a Sokol POA network, which is our testnet, and mainnet for the POA is a core network. So you can also specify your custom RPC port URL in MetaMask. So for these purposes, we're just going to use the local JavaScript VM environment. So it's just basically our fake Ethereum representation of the network. So when you deploy a contract, you get your contract address. And I can see that by looking at the transaction details in a Remix. So I made this transaction with some of the set of parameters, gas limit, how much it cost me, and I do have a transaction hash, some of the data, input data for this particular transaction, and how much value I set when I executed the transaction. So this transaction generated a unique contract address, which allows us to interact with this contract. So right now we only have one public method. It's called something. If I execute it, and I did, and it returned me the value of 0, because by default all the unsigned integers are assigned with a 0 value. So this contract is pretty boring and doesn't allow us to do anything. So let's define the setter function so we can set some value to this variable. So let's say we define the setter method. We need to have one parameter. We specify the visibility of this method. If you don't specify it by default, it will be public, but you better specify what's your intention of this method. Private methods, of course, could be only invoked within the contract, so it's not available for the public. And there is also internal methods. So let's say here we want to set some value to this private variable.
Is internal for cross-contract within the same soul file, or is it
Right.
classes?
Yes, you're correct. So the question was if the internals was for the cross communication with from the contract to contract. Yeah, I believe so, but probably I need to double check on that. So let's call this set something function. And so since I modified the code of this contract, the previous contract address doesn't have this function, so I need to redeploy the contract. That's why it's like this all decentralized blockchain technology. It's a public ledger with immutable data. If you deploy the contract, you cannot fix a bug or add a function. You need to redeploy completely new contract. With every new contract that you deploy, you're losing the storage from the previous contract. So the storage has in a contract address. Every contract has its own storage. I will say it like this. So now we deploy the new contract. It's a new transaction deployment. We get a new contract address, and we can call this public function. Let's say we can set some value 23, and it executed successfully. And now if I call this public method something, it returns me the value of 23. So now, since let's say we are ready for the prime time and we want to deploy this contract to some network. Yes, go ahead.
Just want to ask if someone has any question, then let's ask a question.
Yes, you can.
Lots of new concept and
Right.
Please ask a question.
So let's say we don't want to use this fake Ethereum network anymore, and I want to deploy to real network. So I would select the injected Web3 environment, which means the MetaMask in this case. So now I want to deploy this contract, and then MetaMask pops up and it asks me to sign this transaction. So what is transaction? Transaction is basically I can better show it on the Web3 documentation. Let's say we go to a method called send transaction. So the transaction basically has like a from address to address, the value, ether value, gas meaning gas limit. So gas limit is the value that you allow these transactions to spend. So everything in the Ethereum world is cost gas. So you have to pay for every single computation for every single byte in your transaction. And you can set some gas limit. Let's say I'm okay to spend this amount of gas for this particular transaction. It doesn't necessarily mean that the whole gas amount will be used. So the remaining, if your transaction costs less gas than you set the limit to, this is fine, the transaction will be successful and the remaining gas will be refunded, unused gas. And the next value is gas price. This is how much money you are willing to pay for each gas unit. So that's how you can calculate the transaction cost, which I'm gonna show you later when we deploy to the real network. Data is the kind of most important field. That's what kind of data you're passing in, whether it's a deployment of the new contract. It's a byte string containing the data, or maybe it's a data that if you decode this data, you can see like, oh, you're trying to call some method on the particular contract or some function call. And the nonce. The nonce is So from every account you have to send the correct nonce, and you cannot so the nonce equals to total transaction count made from a particular account. So it has to be correct in order to be mined. So let's say if I made 100 transactions, the next transaction should have a nonce equal to 100. If I send the nonce to 101, the transaction will not be mined until some transaction will be sent with the correct nonce. So right now we deploy this contract when I click create to Colon network, and I can see this transaction on the public Ethereum Explorer for this particular chain. So, and I do have some information here like transaction hash, block number, or the timestamp, it's from account, and basically since we created a contract, the actual to value is null or like zero address, and it returns the new address of the contract. It's just the way the Etherscan represents me those values. And I didn't send any money along with this transaction, so the value was zero. The gas limit was 108,000, and the whole gas limit was spent for this transaction. I could set up a higher limit just to make sure if I don't know how much gas it will cost me. The gas price was set as a 1 gigawatt, so the transaction cost is gas price multiplied by gas used, so that's how much ether was deducted from my account. So if I don't have any ether on the account and I want to call a function that will change the sum of the state of the contract, I have to pay some money to execute this function, and this fee is collected by the miner who validated this block. And we can see that by looking at the block that it says mined by this validator. So this validator collected the fee that we sent with this transaction. So if we look at this contract, we have this tab called contract code, and right now it's just showing me the bytecode for this particular contract, and we can verify this contract on Etherscan. So in order to verify this contract, I have to, so basically contract verification is the process so that everybody who wants to participate with this contract, they can see the code, they can see what they're interacting with. So in order for the contract to be trusted, it's highly recommended to verify the contract, so everybody can see the value. At the same time, it creates some risks for you. If your contract has a vulnerability or bug, people can read your code and exploit your contract. So we do have the source code of this contract, and I'm just gonna paste it here. The name of the contract is Hello World, and I need to specify which compiler version was used when a contract was deployed. So I can go to settings here, and I know it's 0.421. So no matter what kind of version I specified here, what matters is which compiler I used. This is just means which version I require for compiler to be. So if I said 15, so it also satisfies this requirement if I deploy this contract, but the actual compiler that was used to deploy this contract and compile this contract is the compiler that you use. Like in this case is 0.421. But if I remove this one, it says, okay, I have to be very strict about compiler, and it has to be 0.415. So it's using somewhere for the versioning of the Solidity. So I can specify 0.421, and it asked me, did you use any optimization? So I didn't have the enabled optimization when the contract was compiled, so I will select no. So then it asked me, was there any constructor arguments provided? So the constructor is Same way you would have the constructor in your Ruby or some other language. Since we didn't have a constructor, that means the constructor, it was just empty. There was no arguments to the constructor. So I don't need to pass any encoded values for it. The next one is the libraries. Was there any libraries used for deployment for this contract? No, we didn't use any libraries. So what is the library? The library is a way for us to delegate some of the computations to some other smart contracts. So at the time to reduce the gas usage for deployment of a contract. So in our case, we don't have any of those. And I'm just gonna verify and publish the contract on EtherScan. So once it's verified, it will give me two things. It will just have the same source code that I provided. So right now, EtherScan is compiling this piece of code that I gave it, that I provided, and it's trying to match the bytecode. If the bytecode from the transaction is matched with the bytecode generated that I provided, and if it's correct, it says, okay, yes, you successfully generated and the bytecode was matched. So here is your ABI, contract ABI. What is a contract ABI? Contract ABI represents for application binary interface. So it's basically array, it's a JSON array to help me communicate with this contract from any other language like JavaScript, or if I want to write a D app. So I will show you what I mean by that. So this is our verified source code. It's the same source code. And this is the ABI. This is our contract creation code. So, and we can see some public values. So right now the public value of variable something is equals 0. So every function in Ethereum that is returning some value without changing its state is free to call. It doesn't cost any money. That's why when we have this public view keyword view or constant, that means I just want to return something and I'm not intent to change any state. So let's call this function called set something. So EtherScan does not allow me to call any function, so I have to use some Ethereum client, some Ethereum wallet to interact with the contract. So I can use myetherwallet.com. It's a Ethereum wallet application with a bunch of features like generating wallets, sending Ether, interacting with contracts, and checking the transaction. So here I'm interested in a Covan network. So it just basically it's a drop down of which network I want to interact with. So in our case, it's a Covan network. That's where we deployed our Hello World contract. So if I go to contract tabs, I need to provide two things, the contract address and ABI. So the ABI is just the way it specifies what kind of methods and parameters this particular contract have. So I need to copy this value and the contract address. And I click access. So now it reads this ABI and it tells me you have two functions. One of them is something which is a public function and it returns integer, and the other one is set something. So, and it understands that there is one parameter which expects me to provide some value. And then it asks me how would you like to access your wallet. In this case, we're using MetaMask wallet, so I can click connect, then I click write. So my Ether wallet calculated the cost of this function, and it said to me like this is gonna cost you 41,000 gas So that's why it's specified as guess limit. Sometimes if your Ethereum client cannot estimate the gas limit, you either have to like provide it yourself, or that means the gas estimation function wasn't able to execute because there is probably some restrictions in these functions and you will not be able to call this function. So there is a mechanism to predict whether your function will be executed successfully or not. So I will click generate transaction, and I just basically sign transaction, and I'm gonna say okay, make sure, yes, I want to make this transaction. Same way we deploy the contract. I'm gonna click confirm, and now I can view my transaction. It was already mined that quickly because we interacted with a Coven chain. Coven chain has a block time of 3 seconds, so every 3 seconds there is a new block. So we are waiting for Etherscan right now to process this transaction into their own database. So they're basically scraping every single block, and they're reading from each block, they're reading all the transactions, and once they read that, they're inserting this data into their database, and so we can, later on we can see that. So here we go. So we can see that that was the interaction with this contract. There was a function called set something. The reason why Etherscan knows the name of the function is because we verified the contract. So if it knows that it was, so we can see the actual transaction, let's say from here, transaction status. If I provide a transaction hash, I can see that the input was like this, and we know that we call the function called set something, which is basically, so the way Ethereum translates that, it's basically a SHA-3 function of set something, and the argument was unsigned integer. So if we look at the maybe like this, so basically maybe I'm doing some typo or something. So basically the first X amount of bytes has to match with this method signature, this the first bytes in your input data. So that's how it knows that we executed this function with the argument 1, 2, 3 or something. We can check right now. So we can go to read smart contract, yes, and now we successfully set the value to 1, 2, 3, and we can call it from anywhere, either my Ether wallet or any other Ethereum client to read the value. That was just like a very basic thing that you can do in Solidity. So then we can.
Hey, Roman,
Yeah.
I had a question with, so how do we know, does the API have enough information to tell us whether calls, like it's a view call or like, because the views, is it correct to say we don't create a transaction when we're calling like a view function? But
Yes,
the state change does. Do we know from the ABI what
right.
that distinction?
So the question was if the ABI contains information about the visibility of the function, whether it's going to be a state changing function or not. Yes, there is an information in the ABI. It's called state mutability, and you can see that it has the type of view, and this is the function. So yes, you can see that. So for other things that like there is so much things that you can do in Solidity, like you can write a contract that will deploy another contract, or if you want to like restrict the access, who can call those public functions, you can definitely do that. There are like some the global variables like message sender means who is the person is trying to call the contract, and let's say we want to restrict this to the owner. Owner is not a defined variable, so we have to define it. There is a type of the variable called address in Solidity, and we can define it here, and then at the time of deployment we can set the value, set the variable value to the message sender. So in this case I'm just gonna switch back to a fake Ethereum node, and I'm gonna create this transaction. So it automatically set the value to the address that it was called from. So right now, if I want to call the method set something from different address, the transaction will be failed because I'm not the owner, and because, yeah, as we can see, the virtual machine error revert, and we can debug the transaction. We can see it went over here, and it's like, no, this check was executed, and the revert opcode was sent to the transaction. But the actual transaction will be recorded in a blockchain, and you will spend your gas, the gas that was used to execute this transaction, because it still required the computation from the miners to run this code, and you still have to pay for it. So I think the next one will be Mason. He's working on a Elixir Ethereum client.
Yes.
Please welcome Mason. Yeah.
Thank you, Roman.
Yeah, and by the way, if you have any other questions about Solidity, I know I had a limited time to explain a lot of things, so you can always reach me out on Slack or Telegram, and I will be able to answer your questions. Yeah. Cool. Mm-hmm. Yeah.